Okay, this will be for the con assignment, linear versus exponential growth from data. All right, so the basic formula for exponential growth it's going to be y equals a times b to the power of x. Okay, and if you plug in 0 in place of x, you have a times b to the 0, and anything to the 0 is actually 1. So that's going to be y equals a times 1, which is just y equals a. So the letter a is considered your initial value. Okay, just keep that in mind. But this is going to be the basic equation for the exponential function. Okay, so here the number of branches on a tree after the year 2000 is represented by the following table. Which model for b of t, the number of branches t years after the year 2000, best fits the data? All right, so basically we can see this is increasing by a different amount each time. Okay, so it's definitely not linear, which means for this exercise it has to be exponential. It's going to be one or the other. So first I'm going to start with 23 divided by 16. And really you can do this for any two. Like you could also do like 99 divided by 69. It's going to be about the same thing. But if we do 23 divided by 16, I get 1.4375. Okay, and just to prove it to you, let's do 99 divided by 69. I get 1.4348. Okay, so in both cases, if we round it off, it is approximately 1.43 or 1.44. Okay, but now the problem is these jumps on the left hand side, these go up by 2 each time. Okay, so what we're going to have to do is take however much this increases by each time, we're going to have to take that root of this number. Okay, so in this case, it's going to be the second root of 1.44 because this went up by 2 each time. Okay, so that's the root we're using. And of course, as you know from previous, the second root is just the same as the square root. So the square root of 1.44 is 1.2. Okay, so using our equation, y equals ab to the power of x, the initial value at time 0 was 16. So A is just going to be 16, and B is going to be 1.2 to the power of x. So whatever answer is closest to this will be our answer. Okay, and bear in mind, they may use different variables. Since it says after the year 2000, this x may be a t for time. See, they said t years, So the x might be a t, but still this is your basic equation. So let's see. 16 times 1.2 to the x. Okay, and that is answer C. That's the closest one. 16 times 1.2 to the t. Okay. You could see it can't be answer A and it can't be answer D because those are linear functions. Okay, A and D are actually of the form y equals mx plus b. Okay, this part here is your mx and this part here is your b, but there's no exponent in A and there's no exponent in D. So it's answer C. All right, so here we're looking at the data for the oak tree and the birch tree. All right, and this is the number of branches. Okay, and this is pretty easy because each of them will have to be linear or exponential. Okay, remember that linear goes up by the same amount each time, and exponential goes up by the same multiple each time. So let's look at this one here. These all go up by 3 each time, but we have to look at the y column here, the branches. This goes up by 12. This goes up by 13. This goes up by 11. Okay, so it's about the same each time. It goes up by about the same each time. So it's approximately linear. Okay, it's definitely not exponential. But now we look at the birch tree. All right, 33 minus 8, that's 25. And then 128 to 33, that's going to be 95. And this is almost 400. Okay, you can see it's not going up by the same amount each time. So this is going to be exponential. All right. Um, Basically, 25 times 4 would be 100 times 4 is 400. And this will go up by about 1600. Okay, it goes up by the same multiple each time. Okay, so the birch is going to be exponential and the other one is linear. Okay, the birch is exponential and the oak tree was linear. All right, let's see. So, a massive sample of the chemical element after it's initially measured is represented by the table. Okay, and this is after T weeks. All right, so this is every 3 weeks. All right, and again, we can see that it's not increasing or decreasing by the same amount each time. This is definitely exponential. Okay, so we can divide any of these, like I said before. We could do 201 over 400, or we can do 12 over 24. Okay, in both cases, it is approximately 0.5. Now, remember what I said before. This goes up by 3 each time. So that's going to be your root of this. Okay, so we're going to take the third root of 0.5. So on the calculator, just put 0.5 to the power of 1/3. And I get 0.794. Okay, so I'm assuming they're going to round it to at least 2 decimals, if not one. We'll say 0.79 for now. So remember the exponential equation. Y equals a to the bx. At time 0, the initial value is 400. So y is going to equal 400 to the power 400 times 0.79 to the power of x. And again, this x might be a t. So there you go. 400 times 0.79 to the t. All right, another exponential versus linear. All right, I think in the x column, it's always going to go up by the same amount each time. You can double check it if you want. This one obviously counts by 5. This one counts by 6, so we don't have to worry about that. So over here, I'm just going to estimate 300 minus 50. This goes up by 250. And then 1950 minus 300. This goes up by 1550. Okay, so it's definitely not linear. It's not going up by the same amount each time. So this is going to be an exponential. Okay. Like I said, for these, the only choices will be exponential or linear. Okay, this one here, 450 minus 10, it's 440. 890 minus 450, again, it's about 440. And you can see it's going to be about 440 every time. This one is definitely linear. Okay, so the dog video is linear and the cat video is exponential. Dog video linear, cat video exponential. All right, let's do one more. Okay. Cost of buying a small piece of land in a village is represented by the table. What's the model? What is the model for C of T? All right. So like I said, this column always goes up by the same amount each time. So that's a plus 2. And over here, I'm pretty sure this one's going to be linear. Okay, so this goes up by approximately plus 7, plus 7. Yeah, it goes up by the same each time, plus 7. Okay, but the y goes up by 7 every time the x goes up by 2. Okay, so remember the formula for slope. It's change in y over change in x. So in this case, the change in y is 7 and the change in x is 2. And the initial value at 0 is 30. So y equals mx plus b is going to be y equals m, which is 7 halves, times x plus b, which is 30 in this case. 7 halves is the same as 3.5. So 3.5t plus 30. See, they use t instead of x, but it's the same thing. The 7 halves is 3.5. So you could just tell by looking at it in most cases. All right. This goes up by about 300, about 300, about 300. I can tell this is linear. And this one goes up by about 120. About 120 again. I'm pretty sure this is going to be linear on the bottom as well. Yeah, 120 each time. They're both linear. right, one more of these. All right, let's see. So obviously this goes up by 5 each time. And let's see. This goes down by 50 each time. Okay, so it's linear. It's going to be y equals mx plus b. Okay, the slope is the change in y over the change in x. Okay, for all of these, the column on the right is going to be y. Column on the left is going to be x. The change in y is negative 50 because it decreases by 50, and the change in x is 5. So our slope is going to be a negative 10. And our initial value at 0 is going to be 401. So that's your b. So y equals mx plus b. Y is going to be negative 10x plus 401. Okay, and that x might be a t, just so you know. Negative 10x plus 401. Negative 10t. 401 minus 10t. Same thing.